Okay, so we're going to finish out the notes for today with 3 more problems from the PowerPoint. And for the most part, the strategies that we looked at on the previous problems on the other video cover most of what's on the worksheet that you're going to do for this first snow day. But I want to look at 2 or 3 of these just because there's several left and because these are structured a little bit differently. Everything we've worked so far, we started with an expression and we've been told just to simplify it. We don't really know where we're going with it except that we want something simpler. In the next problems and on the worksheet you'll do today, you know what you're starting with and you get this little arrow and you know where you're going, or it might say change this to this. So we have a little more focus on this one because we know where we're headed, and that's helpful when you have things like this where you don't necessarily end with a single number or a single trig function. So we're going to start with the left side, secant x minus cosine x, and we have to magically make those 2 terms condense down into a single term with a sine and a tangent in them. So there's nothing real obvious that pops out at first. So what I might want to do is use a strategy where I just need to subtract 2 terms. And the only way I can subtract 2 terms is if I have like terms. And the only way to get like terms is to make these into fractions with a common denominator. So it's a good trick that works for lots of trig expressions. One thing I could do is just go to sines and cosines. So I know that secant will change to 1 over cosine. And of course cosine's already a cosine, so we'll leave it alone. And then if we can get those 2 fractions, which this second one is over and understood 1, if we can get those to have the same denominator, we could combine them into a single term. So I want the second one to have a denominator of cosine just like the first one does. So we're going to multiply it by a form of 1, cosine over cosine. And that's going to give me a 1 over cosine from the first term minus, multiply straight across, we get a cosine squared in the numerator. 1 times cosine is cosine in the denominator. And now we have common denominators and we can combine those 2 terms. So 1 minus cosine squared is the numerator. Cosine is the shared denominator. We should be starting to recognize this 1 minus cosine squared. We're seeing a lot of it. So I'm going to do a little work to the side here just to see a little shortcut. If we're not already seeing it, it's time to start seeing it. We have a Pythagorean property that says that sine squared plus cosine squared equals 1. If I move the cosine to the other side of the equation, so subtract it from both sides, I'm going to end up with sine squared equals 1 minus cosine squared. So 1 minus cosine squared is always equal to sine squared. In the same way, a 1 minus sine squared is always equal to a cosine squared. Same trick, we just moved a different term. So I can replace this 1 minus cosine squared with a sine squared without having to do the extra work of changing the 1 to a sine squared plus cosine squared and then canceling the cosines. Once I get to this point, I'm trying to make that term turn into a sine times tangent. Okay, so how can I've already got sines. Oh, okay. The numerator, I could actually split up as a sine times a sine. I don't actually have to write that down separately, but it's helpful to see it at least the first couple of times. If I break that into 2 factors and put the second sine over the cosine, if I think of that as a quantity by itself, then I can bring down the first sine, and then the sine over cosine makes a tangent. And that's exactly what I was looking for. So I've changed 2 terms into 1. It's a little bit longer. There's always more work involved when we have to change addition, subtraction to multiplication. So that's a new trick, but we're going to see it pretty often in the days to come. We're going to look at 2 more examples and call it a day, for notes anyway. So the next one is 1 minus cosine squared over tangent. We want to change it into sine times cosine. Okay, so 1 minus cosine squared, I'm just going to rewrite it. And that 1 minus cosine squared, that's looking really familiar. I just saw that one. I know it's equal to sine squared. So we'll just replace it with sine squared x over the tangent x. My goal is to make that turn into a sine times a cosine, which means I need tangent to not be a tangent. I need tangent to be written in terms of sines and cosines. So I'm going to just use the quotient property to change the bottom. So the numerator is going to stay a sine squared. I'm going to change the tangent to a sine x over cosine x. And you'll notice that I'm keeping a long fraction bar and then a shorter fraction bar because I want to think of this as sine squared in the numerator and I have a fraction in the denominator that I'm dividing by. I know that to divide by a fraction means to multiply by its reciprocal, so I want to take the numerator, sine squared, which is over and understood 1, and multiply it by the reciprocal of the denominator, which is a cosine over sine. You want to be careful about doing any canceling of signs here because they're in the numerator, and what often happens is if we try to cancel those, we end up with something that's upside down when we're finished. Denominators cancel nicely. Numerators in these complex fractions, not so much. Okay, so one of the signs in the numerator will cancel the sign of the denominator, leaves us with a sine from the first factor times a cosine from the second factor, which is exactly what we wanted, so we're finished. All right, one more. Last one. We start with two fractions. We want to combine those to make a single tangent. Okay, so I'm going to repeat a strategy that I've already seen. I want to put these two fractions together because I'm trying to go to a single term. And the only way to combine those is if they have a common denominator. This one has a cosine in the denominator. This one has a sine in the denominator. Both denominators have to have both of those factors. So I need to get a sine in the first term and a cosine entered into the second term. So I'm going to bring down the first term, cosecant over cosine, and I need to multiply it by a form of 1. And I need it to be sine y over sine y so that I can get a sine entered into the denominator. Minus, let's bring down our second term, cosine y over sine of y. And we're going to multiply this one by a form of 1. That's cosine over cosine, and that will introduce a cosine into the denominator. Alright, so we're going to combine this into a single fraction with a sine y cosine y in the denominator. In the numerator we have a sine times a cosecant minus cosine times cosine is cosine squared. Now, if we're kind of savvy, and we've got to learn to be savvy, in this numerator, that very first term, I know that cosecant is 1 over sine. And so that should cancel a sine. Reciprocals always have a product of 1, so that's going to become a 1. I can go ahead and just do it right there and bring down 1 minus cosine squared y over sine y cosine y. I know from lots of repetition that that numerator is equal to sine squared. And one quick canceling, sine cancels, and that leaves a sine in the top and a cosine in the bottom. And we know that sine over cosine is a tangent, and that's what we wanted to go to. You won't see the adding fractions popping up on the first worksheet, so we're working ahead a little bit here, but the next worksheet we're going to be seeing quite a few of these, so we'll get really good at it. In the meantime, you have one worksheet loaded on Blackboard. That is your snow day work, and have a good rest of your day.